decimal inequalities. We're going to use the trick that we learned in our last unit for eliminating decimals so that as we solve these inequalities, we'll actually be working with all whole numbers until the very last step. So let's look at example 1 together. In example 1, we have 1.4x minus 1.8 plus 2.35x is greater than 0.21. As you look, notice that we have two decimal numbers that have 2 digits after the decimal, so we're going to need to multiply each of our terms by 100 to eliminate the decimals. So let's do that. 1.4x times 100. Remember, we just moved the decimal twice, so that's 140x minus 1.8 times 100, that's 180, plus 2.35x times 100, 235x, is greater than 0.21 times 100, which is 21. Now, as we get ready to solve this inequality, we've got to notice something important here. We have 140x and 235x all on the same side of the inequality. That means we just simply combine them. We combine positive 140x and 235x to get 375x minus 180 is greater than 21. Now, let's think about getting our like terms together on one side and our constants together on the other side. I have 375x on the left, no x's on the right. So that means all my like terms are together. Now, let's get our constants together. Let's add 180 to both sides. And we get 21 plus 180, which is 201. So we have 375x is greater than 201. In order to get x by itself, we're going to need to divide by 375 on both sides. Now remember, we started this equation, this inequality with decimals. We're likely to get a decimal answer. So I'm going to grab a calculator and I'm going to divide 201 by 375, and I get that x is greater than 0.536. So there's my inequality answer. Now let's go ahead and graph this. Let's draw our number line. Okay, 0.536 is just a little past 0. I'm going to put an open circle on 0.536 since x cannot be equal to that. And x is greater than 0.536, so 1 is greater than 0.5, 2 is greater, 3 is greater, so I want my arrow pointing to the right. Example 2, we have negative 1.7y plus 6.7y is less than or equal to 13.1. Notice that each of our decimal numbers have just a single digit after the decimal point, so we can multiply by 10 for each term to eliminate the decimal. 10 times negative 1.7y is negative 17y. 6.7y times 10 is 67y. And we have our less than or equal to sign. 13.1 times 10 is 131. Notice as we get ready to solve this inequality, both of our variable terms are already on the left-hand side, so we just need to simply combine those together. We have a negative 17 and a positive 67y. We're going to subtract. 67 minus 17 is 50. It's going to be a positive 50y is less than or equal to 131. Now we need to get y by itself. In order to do that, we're going to divide on both sides by 50. We began this problem with a decimal, so we're going to most likely end with a decimal answer. So we're going to grab a calculator and we're going to divide 131 by 50. When we do that, we get an answer that says y is less than or equal to 2.62. 2. So we graph that inequality. We draw our number line. We put 0 to separate our positive and negative numbers. We plot 2.62. We're going to put a closed circle on 2.62 because of our equal to sign. And it says that y is less than or equal to 2.62. So numbers smaller than 2.62 are back here to the left. One final example. We have negative 1.4 is greater than negative a plus 2.8. Remember that sometimes it's helpful when we have just a variable to go ahead and put a 1 in front so that we see that as negative 1a. Now, we have two decimal numbers. We have negative 1.4 and we have 2.8. Each of those have a single digit after the decimal point, so let's go ahead and multiply by 10 to eliminate our decimals. We'll have negative 14 is greater than negative 1 times 10 is negative 10a plus 2.8 times 10 is 28. Now let's go ahead and solve. Notice that we have one term with the variable, that's negative 10a, and that's already on the right-hand side. So we're going to need to get our constants moved onto the left. Let's take away 28 on both sides. Negative 14 and negative 28, they're both negative, so we're going to add those together and get negative 42 is greater than negative 10a. We're going to get a by itself by dividing by a negative 10. Remember, what does that mean? On the variable side, when I have to divide by a negative number, that means we flip our inequality sign. So let's go ahead and flip the greater than symbol to a less than symbol. A is on the right-hand side of the inequality. Now let's work this division. 42 divided by 10 is 4.2. A negative divided by another negative is a positive. So we have 4.2 is less than A. If you prefer to rewrite that with the A coming first, we can do that. We just need to flip the sign. We'd make that A is greater than 4.2. Again, both of those answers communicate the same thing. They communicate that A is greater than 4.2. Let's go ahead and graph that. We're going to put an open circle on 4.2 because A cannot be exactly 4.2. And the numbers greater than 4.2 are to the right. Numbers like 5 and 6 and 7 and so forth.